problem exemplifies something we're going to do a lot of in the class, and that is find the graph of a derivative from the original function. Or then later on, we'll also, from the graph of the derivative, find the graph of the original function, f. So in this one, they're given the original function, f, and we're told to graph the derivative function based on that. Well, we realize right off that f prime of x is the slope values of f of x, because we've just found out that the derivative of f is the slope of the tangent line. That's one of the meanings of the derivative, slope of the tangent line. So if we just look at our function over here, one segment at a time, let's key in on this segment right here. Well, that's a straight line, so that has a constant slope. So the slope from -5 to -3 will be all the same slope. And what slope is that? Well, it's over 2, up 2, so the slope is 1. So on our derivative graph, as we go from -5 to -3, we have a slope of 2. So a value of 2. So it'd be, now I'm going to put open circles, and that's going to be for a reason that we're going to explain. Now, I'll explain in -5 why that's open circle at the end, but there's an open circle at -3. And the reason is that the derivative is undefined there. And that is because when you come toward -3 from the other direction this way, the slope is different there. The slope is actually -1 if you count the grids there. And at this point right here, -3, -2. I'm sorry, -3, 2. There's a sharp corner there. The derivative right to the left is 1. The derivative right to the right is -1. And if you come over to the limit definition of the derivative, you'll see at x equals -3, the limit as h goes to 0 from the plus side, you do the difference quotient, it comes out -1 because the slope of that tangent line is -1 here. -1. This line here has a slope of -1 coming from the right. Now, if you come from the left, so h is negative. H can be negative. Now you're on the left side of x equals -3, and now you're dealing with slope values that are equal to 1. So the limit as h goes to 0 from the left of this difference quotient comes out to be +1, and -1 is not equal to 1. So the overall limit as h goes to 0, which is what the derivative is, it's the two-sided limit from left and right have to match up of the difference quotient. They don't match up, so it's undefined at x equals -3. So there's no point to graph. So at -3, we have this open circle. Now there's an open circle at -5, because as you can see, at -5, there are no points of f to the left of -5. So when your h is negative, coming towards 0 from the left, there's no function values for corresponding to -5 plus a negative h value coming from the left. So those values are undefined. So that's why you have an open circle also at points on the end. Then let's continue on. There is, as we noticed, the slope is -1 all the way till you get to 0. So it's -1. I'll do that like this. -1 until you get to 0. Now at 0, there's also a sharp corner where the slope doesn't match up on the two sides. So there's going to be an open circle there too. Then from 0 to 3, you have this segment, also constant slope because it's a line. And what is the slope of that line? Go over 3 and up 1, 2, 3, 4, 5, 6. 6, 4, 3. So it's a slope 2 line. So we go up to 2, and you have your open circle, and that's good all the way till 3. And there's an open circle at 3, because again, we have a sharp corner where the slope on the left is 2, and the slope on the right is 0. So that would be back down here. And we would go to 6 and have an open circle because the function terminates there. And we would have that answer.